Can you see my screen?
Yes, sir.
Yes, sir.
Okay, so today we are going to start the second section, which is differential calculus. These are the topics we are going to see in this section. First, we will see what. So this is a differential calculus for functions of 2 and more variable. So keep this in mind. So everything that we are going to discuss in this section, it will be for function of 2 or more variables. In your high school, you have seen functions of one variable. Right? Function
Yes,
of one. Sorry. Okay, so this is you have learned in your high school, and there you have seen what do we mean by limit of a function, what do we mean by continuity, what is differentiability. Okay, right, maxima, minima. So all these things you have done in your high school. The same thing we will discuss for a function of two or more variables. Okay, but this generalization is not that much straightforward. It's not trivial generalization. Okay, so you'll see several new things coming up and new ways to tackle this generalization. So these are the topics we are going to see. First one is the limit, continuity, differentiability. Then we'll see Euler's theorem and some discussion on tangent and normal plane. Then change of variable. The change of variable will be used in integral calculus also. Like you have seen change of variable for a function of single variable in your high school, where by making the transformation, you are able to simplify the calculation of the integral. So something similar here also we will do. Sometimes to simplify the calculation, we will do the change of variable for functions of more than two or more than two variables. So sometimes it will be used for simplification. Sometimes it will be used to calculate. In fact, sometimes you cannot even calculate this integral. Okay. Then you will see the chain rule. Chain rule you have seen in your function of one variable also, and it's related to this. We have Jacobian, and then Taylor series expansion for function of two variable. Using the Taylor series expansion, we will see how to find the approximate value of the function. And when the function is approximated using the Taylor series expansion, then how much error we are going to commit in this type of approximation. Okay, then extrema of the function, that means maxima and minima. And then Lagrange method of multiplier. So you should note that for the MTE, for your midterm examination, which is going to happen between 10th of January to 12th of January, the last topic is not covered. This is not part of MTE. This is not a part of. Okay. So before this, everything will be asked in your midterm examination. So you already may be aware that in the midterm examination, you have one midterm examination where you have 10 questions that you have to solve in 1 hour. Okay. And there will be, along with the MT, there will be a quiz which will have 15 questions. This will be of multiple choice, MCQ. The MT examination will consist of 3 types of questions. One is MCQ, where you will be given 4 options, and one of the options will be correct. Then MSQ, where you will have 4 options and more than one of the options will be correct. And then you have fill in the blanks. Okay. In fill in the blanks, you have to do some calculations on your copy at home, and then you have to write your final answer uh, for the solution. So all these quiz as well as the midterm examination, everything will be conducted on the Moodle platform. Okay. So if you're not familiar of Moodle platform, we will have a mock quiz, mock test, where you can log in and then check whether everything is working or not. So if you face any problem, you can write to me or to the coordinator, which is Professor Sukavna, and the another deputy coordinator is Surojit Ghosh. Any three of us you can write. Even you can write your lecture teacher, and then they can forward your request to us. Okay. So Moodle platform, we will have a mock test. You must appear for this mock test so that you get familiarized with the Moodle platform if you have already not seen it. Okay. Because if you start using Moodle platform without having any experience, and in case you face difficulty there during the time of the test, then nobody can help you. Okay, so that is why it is important that you familiarize yourself with this Moodle platform, and you should join this mock test. The date of the mock test will be announced soon. Okay, so and I will also try to send you all the slides related to these topics, so that you can also do self study to prepare for the MT examination, because we do not have enough days to, I mean, if once you have all the slides, then it is easier for you to do the preparation.
सर
Yeah.
सर मेल किस काम के लिए लिखना था सर?
मतलब
सर आपने बोला था ना कि आपको मेल लिख सकते हैं, या फिर एक और प्रोफेसर बताए थे उन्हें मेल लिख सकते हैं नूडल प्लेटफॉर्म के लिए कुछ.
So there will be a mock test few days before the examination, few days before the MT examination. And if you face any difficulty in accessing Moodle platform or any sort of problems related to Moodle platform, then you can write to us and we will try to resolve it. So you can write to, so you should visit the course website, where the name of the course coordinator, and 2 names of the deputy course coordinator. I am one of the deputy course coordinator. So you can write to them if you face any problem in the Moodle platform. If you have any internet issue, then you should not write to us, because internet issue we cannot solve. But if there is something which is related to only specifically only to the Moodle, then you can write to us so that we can resolve these issues before the midterm examination. Fine.
Yes, sir. Fine.
If you have any internet issue, if your device, you have some problem with your device, that we cannot solve. So only related to Moodle platform. Okay, so now let us start this section. So we are going to see some definition first. So first definition is how do we define the function of two variables? So we say that a function of two variables is a rule of correspondence that assigns a real one and only one real number z to each ordered pair xy of real numbers in a subset of R2. So you take an ordered pair xy and then assign one and only one number z to this. Then this is known as function of two variable. Okay. So for example, let us consider this. So here one can clearly see that as long as x plus y square is less than equal to 1, the function is well defined. If x square plus y square is greater than 1, then the function is not well defined. You will get some complex number. Okay. And we are dealing with a function of real numbers, right? A real valued function. We are dealing with a real valued function, and it is a function of real numbers. So we are not going to see anything in the complex plane. Okay. So whenever something goes into the complex plane, we will exclude those cases, right? So this is a real valued function, and for this function to take real value, we must have x plus y, x square plus y square less than equal to 1. Okay. So this is known as the domain of the function, x square plus for all the x and for all x y such that x square plus y square is less than 1. This is known as the domain of this function. And one can see that whenever x square plus y square is less than 1, the quantity inside the square root function is less than 1. That means the value of the function will be in the interval 0 to 1. 0 when x square plus y square is equal to 1, and 1 when x square plus y square is equal to 0. Okay. So this is known as range. This is known as domain of the function. In this case, the domain is the circle of radius 1 centered at origin, and range is the interval 0 to 1. This is range of the function. Fine. Similarly, you can consider the second case where fxy is equal to 1 over x square minus y square. So you can clearly see that if x and y are equal, then the denominator is 0 and the function will become infinity. So this case should not be in the domain of the function. So we say that domain is all values of x and y such that y is not equal to plus minus x. Okay, and the range of this function will be all real uh, numbers except 0, because this function will never take 0 value. This function will take 0 value only when the denominator is infinity, and which is not possible. We do not want x and y to be infinity. Okay, so range is 0, all real numbers except 0. And similarly, you can see that the third example, the domain of the function is all x, y such that x plus y is strictly greater than 0, and range of this function is the whole real line. Fine. So this is about the definition. So we have learned the definition of the function of two variables, and we have done what do we mean by the domain of the function and the range of the function. And we have seen some examples here. Now the variables that we see in the above example or in the function of two variables, they are known as independent variables, the variables x and y. And the variable z, which is the unique value assigned to each tuple xy, each ordered pair xy, this unique value, this z is known as the dependent variable. The value of z is determined by substituting the values of x and y. So that is why it is dependent variable. Okay. So x, y in the example are independent variable and z is the dependent variable. Now we have this, the locus of the point x, y, z satisfying z is equal to fxy is called the surface. Okay. For example, if I take z is equal to x square plus y square, then the surface will be paraboloid of revolution. Okay. And in the same way, we can extend everything that we have seen here up to now can be extended to a function of three variables. So you can also have, you just write the function of three variable, just replace 2 by 3, and you have this ordered pair. You replace this ordered pair by x, y, z, and you say that you get only one and only one unique values, let's say u instead of z. Okay, and the same way you can construct these examples. For function of three variable, x, y, and z will be the independent variable, and the variable u will be the dependent variable. Okay, so all these things can be extended to function of three variables, and in fact to function of more than three variables also. So our primary focus in the discussion will be on function of two variable, because if we understand everything related to function of two variable, some basic extension is needed to extend all these notions to function of more than three variables. Okay. Now the next definition is delta neighborhood. Next is delta neighborhood. So let us consider I have a point x naught, y naught in R2. So this R2 means you have x axis here and y axis here. Then when you say x and x naught, y naught is a point in R2, that means you take x naught on the x axis and y naught on the y axis, So this point will be x naught, y naught. Okay. So if you see this expression, x naught, y naught belongs to R2, this simply means that okay, where x naught corresponds to the x component that you identify on the x-axis, and y naught corresponds to the y component that you identify on the y-axis. Okay, so let us consider x naught, y naught is a point in the xy plane or in R2. Okay, so the delta neighborhood of x naught, y naught is denoted by n. N, capital N, stands for neighborhood, and delta stands for this delta neighborhood. And here you have x naught, y naught. So it is a neighborhood around the point x naught, y naught. So delta neighborhood of x naught, y naught is defined as all values of xy such that this distance, which is the distance of the point xy from the point x naught, y naught, is less than delta. So that means you have, let's say, some point x naught, y naught, and you want to create a delta neighborhood of around this point. So you create a circle whose center is at the point x naught, y naught, and radius of this circle is delta. Okay, and then consider all the points inside this. So basically the plate, you get the plate. So all the points inside this. This will be known as the delta neighborhood of the delta neighborhood around the point x naught, y naught. Any question?
Means sir, boundary is not involved. We are
Boundary,
just working on the area inside that delta.
yes, boundary is not considered here.
Okay, sir.
So what is the difference between this R2 and the original R that we are very familiar with?
Or the difference between R and R2. This is what you are asking.
Yes, sir. Sir.
So R means you are in one dimension. You are taking values on real line. And R2 means you are in two dimension. You have
Okay,
x
both an
axis.
X and Y.
Yeah, we have x axis as well as y axis. So if you consider the space R2, that means you are considering a plane.
Kind of real numbers in two dimensions like X and Y, right?
Yes. So
Okay.
all the points on the plane,
Okay.
xy plane. You have xy plane, so all the points on the xy plane. If you consider R, that means you are considering
Kind of a
all
line. Kind of a line.
No, it's not line. The line is different.
Okay.
Right. So if you are considering all the points on the real line,
Okay. Okay.
not any arbitrary line.
Yes, sir.
Because this is also, you can also have a line here.
Yeah.
You can also have a line in 3 dimension.
Yes, sir.
You can also have a line in n dimension space.
Kind of single dimensional line.
So you when I say R, that means this is a real line, and R2 means this plane,
Yes, sir.
two-dimensional plane. Okay,
Yes, I got
where
it.
the points
Thank you.
will be in the tuple xy, x comma y.
Okay.
X represents the point distance, the coordinate of the x-axis, and y represents the coordinate of the y-axis.
Okay.
Is this fine?
Yes, sir. Perfect.
Sir, why it is delta neighborhood, not alpha beta? What matlab, why it is delta?
You can call it alpha, beta, whatever you want. Delta neighborhood is because mathematicians like to have a consistent symbol. Okay.
Yes, sir.
So because you have a consistent grammar in Hindi, in English. The grammar does not change from person to person, right?
Yes, sir. Yes, sir. I got
So
it.
it is just because of this. Mathematicians decided that we will keep this as delta neighborhood. But so that if I say delta neighborhood, then you will know what does it mean. So if you start changing the notation, everybody has own notation. So you are saying delta neighborhood, somebody is saying beta neighborhood, somebody is saying A neighborhood, somebody is saying B neighborhood, then things will become complicated to understand. So to make the mathematical long language common, they have decided to say that this is a delta neighborhood.
Okay, so this means this is a predefined function.
Notation.
No, sir. After that, the delta neighborhood is actually a function in x and y.
It is not a function. It is a collection of points. It is a collection of all the points such that the distance of this point from the point x naught y naught is less than delta.
Okay, sir.
Sir, I have a question.
Yeah.
Sir, how can we trace the locus of a function in 3 variables?
Sorry.
Sir, how can we trace the locus of a function in 3 variables?
So you can see the example here, because you have this z is equal to x square plus y square. So basically you put a specific value of z. Let's say if I take z is equal to 1, so you have x square plus y square is equal to 1. So this gives you a circle of radius 1 centered at origin.
Yes, sir.
0, 0, right? So
Yes,
you
sir.
can imagine something like let's say this is your z axis. So on z axis you are taking 1, and then at this point you are creating a circle whose center is at z is equal to 1, but xy is 0.
Yes.
Okay, then you change the value of z. Let's say z is 4. So you have x square plus z square y square is equal to 4. So you take z is equal to 4 here, and then there you create a circle. So in that way, whenever you change the value of z, you will start. So z x y z can start from zeros, and then you can trace all the circles all around. Right. So that the space that you get, the surface that you get, is the paraboloid of revolution. Fine.
Yes, sir.
Okay. So now we move further.
Sir,
Uh,
delta is the radius of the circle, right? Centered at x naught, y naught.
yes. Delta square, you can say. Okay. But so basically, when you have, let's say you have this xy here, when you say that we want to create a neighborhood around a point x naught y naught, so there are several options here. You can say that I can have a neighborhood using the shape of the circle. I can have a neighborhood using the shape of a square. I can have a like a neighborhood using the shape of a rectangle, right? So all these are neighborhoods. Okay, so this neighborhood is not unique. This is one way to define the delta neighborhood, right? When you learn more higher mathematics, then you will see that an entirely different definition of neighborhood. But for your course, this definition is enough. So that is why you can see that I have written on this slide that delta neighborhood can also be defined as collection of all the x and y, the tuple x and y, such that x is lying between x naught minus delta to x naught plus delta, and y is lying between y naught minus delta to y naught plus delta. Okay, so if you consider the shape of this one, the shape of this gives you the circle. But if you consider the shape of the second definition, this will give you a rectangle. It is a rectangle around point x naught y naught. Similarly, you can define the neighborhood in this way also, and this will give you entirely different shape. Okay, and the other way you can also say that you have this. No, this will give you the same shape maximum, but this last one will give you this different shape. Okay, so this is I put this as an exercise also here in the next slide. Plot all the delta neighborhood and deleted delta neighborhood defined above. So I have given different ways to define the delta neighborhood. Right. So one definition is okay. So one definition is this one. So try to plot the shape here. The other definition is this one. The other definition is this one. Okay. So basically, you can take any shape around around the point. These shapes are taken because these are standard shapes, and these shapes can be used to solve the problems. And most of the problems you can solve using these shapes. And particularly if you go for much higher studies in mathematics, then you will see that in this plane, R2 plane, all these shapes are equivalent. Right. So if you are solving something using this circle, using the first definition, you can do the same thing using the second definition, the same thing using the third definition, and so on, or using any shape. They will become equivalent. And what is equivalent is something that you will learn in higher mathematics. So I'm not going to discuss all those things here. It will only confuse you and without many much help, in fact. Fine. So basically these shapes are written on the slide because sometimes when you solve the question, this definition will be used, will be easier. Sometimes this definition will be easier. Sometimes this definition will be easier. Sometimes this definition will be easier to solve your question. So whatever is easier, you can use that. Okay, so that is why I have listed all the neighborhood here. Okay, so this is known as delta neighborhood of the point x naught y naught. Now there is another concept which is known as deleted delta neighborhood of the point x naught y naught. So in a deleted delta neighborhood, you have all the same definition except the fact that in the neighborhood you do not include the point x naught y naught. X naught y naught should not be an element of the neighborhood. In all the definition, you can see that if I put x is equal to, let's say if I put in this definition x is equal to x naught, y is equal to y naught, right? So on the left hand side you will get 0, and on the right hand side you have the value delta, and delta is always positive. So whenever you see delta in this section, delta is always strictly positive. Okay, so this condition is satisfied. So that means x naught y naught is always an element of the delta neighborhood. And similarly for the other definitions, you can check x naught y naught is always an element of the delta neighborhood. Okay, when x naught y naught is not an element of the delta neighborhood, then it is known as deleted delta neighborhood. So you basically delete the point x naught y naught from the neighborhood. Okay, right? So you can say that I have a neighborhood and delta x naught y naught. Now this neighborhood can be anything that I have given you. It can be anything here, as per your convenience. Okay. So you have this as delta neighborhood, and you minus this point x0 y0 from this. You exclude the point from this. So this becomes deleted delta neighborhood. Okay. So more precisely, what we can say is that if I do not allow this to be 0, then x0 y0 is automatically deleted. So on this definition, I put another restriction that 0 is strictly less than this square root x0 x minus x0 square plus y minus y0 square. Okay, so then clearly x0 y0 is not an element of this neighborhood. Similarly, in the second definition, this was the second definition here. So in this definition, if I put this restriction, and similarly on y minus y0, then x0 y0 is not a part of this neighborhood. So we can say that this is a deleted neighborhood, deleted delta neighborhood, right? And similarly for the other two cases, in other two cases you have this maximum here. So you add one more condition, 0 is less than this maximum. And in the third case, you have this one. So you do not allow 0 to be an element here, 0 to be, you do not allow this to become 0. So automatically x0, y0 will be deleted. Okay, so this is known as deleted neighborhood, deleted delta neighborhood.
Sir, in this this means now with the boundary we remove as well as the center.
Yes.
And group of point between those two are the result
Boundary,
of
the x0, y0 is just a single point. It is not a group of point.
yes, sir, yes.
Okay, so you remove that point from
And
the
bound.
neighborhood, and boundary is already not part of this neighborhood definition.
Yeah. Yes, sir.
Okay. Right?
Yes, sir.
Yeah. So this is a good exercise for you to do. You should solve this exercise. You plot the shapes. You can take any you can take any specific value of delta and then see the shapes. So let's say if I take delta is equal to 1, and then see the shapes of all these neighborhood. Okay, and then similarly see the shapes of all these deleted neighborhood. So from there you will get an idea what are the possible shapes you can have in the neighborhood, for the neighborhood and for the deleted delta neighborhood. Okay. Okay. So now we go to the next definition, which is limit. Now you know what is limit for function of one variable. So in function of one variable, what do we say? If I want to find the limit of x going to x0 fx. Okay, so how do you calculate this limit? You calculate the left hand limit and right hand limit, and if left hand and right hand limits are same, you can say that the limit exists. Okay, so what is left hand limit? Left hand limit is that you approach the point x0 from the left hand side. Okay, right hand limit means you approach the point x0 from the right hand side, right? So that means when you have a function of one variable, then you have two possible directions to approach the point x0. Fine. So only two possible directions. You cannot have three directions for to approach the point x0. Only two possible. Either you approach the point x0 from the left, or you are approaching the point x0 from the right. When you try to generalize the definition of the limit for function of two variable, then you have to see how many how can I approach the point x0, y0? When you go to the two-dimensional case, instead of x0, I have a point x0, y0, right? And in order to define the notion of the limit for a function of two variable, I need to see what are the possible directions from which I can approach the point x0, y0. So what are the possible directions? How many directions you can think of? Anyone?
Sir, two directions, because we are working on two variables and we can approach a point in 2D from two directions.
And what are those directions?
Infinite directions.
Infinite direction.
Infinite directions.
Infinite directions. Yes, sir. Yes, infinite.
Infinite directions, because I can approach this point from this direction, I can approach from this direction, I can approach from this direction, I can approach from this direction, this direction, this direction, right? And for all the directions, I should get the same value. In one variable, when you go from the left hand side and when you come from the right hand side, you reach to the same value. And if you reach to the same value, that means left hand limit is equal to the right hand limit. And this value is known as the limit of the function. Okay. So that means in order to define the limit of the function, when I approach the point x0, y0 from all the possible directions, I should reach to the same value, and this value will be known as the limit. Okay. And now we are in problem because I have infinite number of directions to approach the point x0, y0. So what to do in this case? So in this case, we define the limit in this way. So we say that a real valued function, we go to the epsilon delta definition. So we say that a real valued function is set to approach to the limit L as xy approaches to x0, y0 if for every epsilon greater than 0, there exists a delta such that the distance between the function f and the limit L is less than epsilon whenever we are picking xy, the point xy, from the deleted delta neighborhood of the point x0, y0. So this is deleted delta neighborhood of this is deleted neighborhood of x0, y0. You have just seen this definition. Okay. So what do we say here? So basically here it means that you have this point x0, y0, and you create a small neighborhood of shape, let's say circle, deleted neighborhood. So this point is not there. In the one variable also, you have already seen that even if the function is not defined on x0, we can still say that the limit of the function at x0 exists if left and right hand limit are equal. Okay, the same notion will. So that means when you calculate the limit, you do not include the value of the function at that point x0 in single variable case. The same thing will happen here as well. When we calculate the limit, we do not bother whether the value of the function is defined at the point x0 or y0. Not. So that means instead of working with the delta neighborhood, we can work with deleted delta neighborhood, where we exclude the point x0, y0. Okay. So this is the deleted neighborhood. So deleted neighborhood means the center is not part of the neighborhood, and then you say that this is the length delta. You shrink this length delta. You keep taking small and small delta. Okay, so then you will reach from all possible directions to the point x0, y0 whenever delta is going towards 0. Okay, so if you do that, then the value of the function will approach the point, approach the value L, and this value L is known as the limit of the function. So this is what geometrically it means. So mathematically we say that. So how to like write this geometric interpretation in the mathematical world? So it says that you choose any epsilon. You pick your epsilon greater than 0. That is the only condition. This epsilon can be 0.1. This epsilon can be 10 million also. Okay, you pick your epsilon as per your convenience. And the only condition is that it should be strictly greater than 0. Okay, so for every epsilon, so you keep in mind this word every epsilon. So you have to test this condition for every epsilon greater than 0. So how many epsilons are there? Infinite number of epsilons. Except 0, you have to accept 0 on the positive side. Except 0, you consider all possible epsilons. So for every epsilon, there exists a delta. So whatever epsilon you have chosen, for this epsilon, you will always get a delta, such that the distance of the function from L is less than epsilon. So if you say that I want to keep the distance 0.01, then corresponding to 0.01, you will be able to find some delta. That means a neighborhood, deleted neighborhood, deleted delta neighborhood. And if you pick your epsilon, let's say 10 million, then also you will be able to find some delta so that you can create a deleted neighborhood here. So if you are able to do this for every epsilon, then we say that the limit exists. So essentially, this means that whenever the size of the delta is going down and down, or whenever you are approaching the point x0, y0, from all possible directions, the value of the function is approaching to the real number L. Okay, so because epsilon can be any large number, it can be any small number. So for every small number, you will have this relationship. So this is known as epsilon delta definition of the limit. And this point that you have, this point is known as the limit of the function. So basically, this is simply a notation for the constant L. And when you write this expression, that this limit is L, it means that you are writing everything, all these things you are writing. So this whole sentence is given this notation. This is a notation for this whole sentence. Right? Mathematics is all about notation. If you understand the notation, then you know mathematics. If you cannot understand the notation, then you do not know mathematics. Okay, so when you see this expression, this means that entire thing. Okay, right?
Sir, what does this epsilon signify?
Epsilon is a very small number, so that Like so you see that in the definition, you see that in the definition, what does it mean? This means the distance between the value of the function and the constant L. So this distance is less than epsilon, and this is a very small quantity, very small number, but not zero. It is a small number but not zero. So it is a small number, but that means f is very close to L. So because we say that this should hold for every epsilon, right? So for every
Yes,
epsilon it should hold. So that means f is very close to L. Just like in
okay.
left hand limit and right hand limit. When you reach to the point x naught from the left hand side and from the right hand side, the value of the function is going towards some constant L. Okay. So
Yes.
that means the distance between f and L is becoming very, very less.
Okay, sir.
Okay. So this is the definition of the limit in two variable case. So you can see that when we started for the generalization from functions of one variable to the function of two variables, even the first definition is not that much simple. The first definition is limit, and it is not a simple definition. So this generalization is certainly not trivial. Okay. Now there are some points here. The definition of the limit applies to the interior points as well as the boundary points. However, points x, y always remain in the domain of the function. Right. So what does it mean? It means that when you create the neighborhood, this what is x and y? The x and y appears here in the neighborhood here and here. So if you have this xy, this same xy is appearing in the neighborhood. So this xy should always be in the domain of the function. Okay, so that means you do not have to, you should not create a neighborhood which is outside the domain of the function. If the domain is, let's say, domain of the function is, let's say, this one, then you cannot create a neighborhood like this because these points are outside of the domain. And if it is outside of the domain, then the function is not defined on those points. Okay. So if you are finding the limit in the interior of the domain, so if this is the domain and you are finding the limit in the interior, x naught, y naught is in the interior of the domain, then you should, you can have this kind of deleted neighborhood. You can also have some other shapes. So as long as these shapes are lying inside the domain of the function, then you are fine. But if you are dealing with if the x and y, x naught, y naught is on the boundary, then you should be careful that you only include the part of the deleted neighborhood which is inside the domain. You will exclude the part of the deleted neighborhood which is outside the domain of the function. Is this clear? This is what this point means. And it is quite natural because you don't want to approach to the point x naught, y naught from the outside of the domain, because outside the function is not defined. So in that way, when the function is not defined, this will have no meaning at all. This is not defined if you approach from outside. So you should restrict yourself from the inside point. Okay, the second point is for the existence of the limit, f may or may not be defined at the point x0, y0. And this is same as you have seen in your high school calculus for function of one variable. Okay. Now the third point is in two-dimensional plane, when you write this expression xy goes to x0, y0, this means that point x0, y0 is approached from all possible directions. I just said this, and that is there are infinite number of paths. So you have this point x0, y0. You can approach this point through this zigzag path also. You can approach this point through this straight line also, and maybe some other shapes also. You can approach through this path, right? So you have straight path, you have polynomial path, you have more complicated path than polynomial, right? So you have several paths to approach the point x0, y0, and the number of such paths is infinite. Okay. And when you go to the point x0, y0 from these paths, the infinite number of paths, you should always reach to the same point. The value of the function should always reach to the same point L. Whatever path you have chosen, the value of the function should always be same for all paths. So that means if you are able to find one path where the value of the function is different from L, at least one path where the value of the function is different from L, then you can say that the limit does not exist. In one-dimensional case, function of one variable, in the one variable case, that means when you approach to the point x0 from the left hand side, and you do not go to the same, the value of the function do not go to the same point where when you approach from the right hand side, then you say that limit does not exist. Left hand side and right hand side, the left hand limit and right hand limit are not equal, so you can say that limit does not exist. So here also we are applying the same definition to show that limit of the function does not exist. Since I have infinite number of paths to approach the point x0, y0, and for limit to exist, the value of the function should approach to the same constant L. So for existence of limit, we have to approach to the same point from all directions. For non-existence of limit, we have to identify at least one path where along this, if we travel along this path and the value of the function does not equal to the constant L, then we say that the limit does not exist. So here you just have to identify a single path where the value does not approach to the constant L. Then you can say that the limit does not exist. Okay. And the next one is limit if exist is unique, that we will see later. Now, today's time is already up. So if you have any question, you can ask me. Otherwise, I can close the session.
सर आपने बोला कि हम इन्फिनिट डायरेक्शन से अप्रोच कर सकते हैं उस पॉइंट को, और फिर आपने बोला कि लिमिट निकालने के लिए हमें एक डायरेक्शन से अप्रोच करना है, अगर उस पर एग्जिस्ट कर गई तो कर गई, ऐसा?
नहीं, मैंने ये नहीं बोला. मैंने बोला कि अगर तुम्हें लिमिट शो करना है, कर रहा है लिमिट, अगर ये तुम्हें शो करना है तो तुम्हें शो करना है कि हर पाथ से आओगे तो सेम पॉइंट पे आओगे. और अगर नॉन एग्जिस्ट कर रहा है, लिमिट एग्जिस्ट नहीं कर रहा है, तब तुम्हें एक पाथ आइडेंटिफाई करना है जिसमें तुम या दो पाथ आइडेंटिफाई कर लो जिसमें एक पाथ से तुम अलग पॉइंट पे अप्रोच कर रहे हो और दूसरे पाथ से तुम अलग पॉइंट पे अप्रोच कर रहे हो। नॉन
ओके
नॉन एक्सिस्टेंस के लिए तुम्हें पाथ आइडेंटिफाई करना है।
तो
दो
सर
पाथ
अभी इनफाइनाइट पाथ बताया सर आपने, तो ऐसे तो सर लिमिट निकल नहीं पाएगी सर।
लिमिट निकलेगी ना, एप्सिलॉन डेल्टा से निकलेगी। एग्जांपल देखेंगे नेक्स्ट क्लास में। ये देखो बहुत सारे एग्जांपल्स हैं। यहाँ देखो एग्जांपल। अभी ये स्लाइड तो तुम्हें मिल भी गई है, तुम पढ़ भी सकते हो। यहाँ पे डिफिनीशन को यूज करना है। क्या है डिफिनीशन? फॉर एवरी एप्सिलॉन देयर एग्जिस्ट ए डेल्टा। तो कोई आर्बिट्ररी एप्सिलॉन चूज करो और फिर इसके कॉरस्पॉन्डिंग डेल्टा चूज करो ताकि ये रिलेशनशिप सेटिस्फाई हो जाए, ये चीज सेटिस्फाई हो जाए। ये चीज तुम्हें शो करना है। तो एक आर्बिट्ररी एप्सिलॉन चूज करो जो पॉजिटिव है और फिर इसके कॉरस्पॉन्डिंग एक डेल्टा चूज करो जो पॉजिटिव है ताकि ये चीज सेटिस्फाई हो जाए। अगर ये सेटिस्फाई कर दिया तुमने, हर एप्सिलॉन के लिए एक डेल्टा तुम्हें मिल गया, तो लिमिट एग्जिस्ट कर गया। तो यहाँ पे लिमिट एग्जिस्ट कर जाएगा, ये जीरो हो जाएगा लिमिट। तो जो तुम्हारा अप्रोच था पहले जो स्कूल में अप्रोच करते थे, एक्स इज इक्वल टू एक्स को लिमिट में डाल के फंक्शन के वैल्यू में डाल के देख लिए, वो अप्रोच यहाँ काम नहीं करेगा क्योंकि यहाँ तुम्हारे पास इनफाइनाइट नंबर ऑफ पाथ्स है। तो तुम्हें हर बार बेसिक जो एप्सिलॉन डेल्टा का डिफिनेशन है उसी पे जाना पड़ेगा। ठीक है। लिमिट क्या अगर नहीं
थैंक यू।
एग्जिस्ट नहीं करता है तब तुम्हें कुछ पाथ्स आइडेंटिफाई करने होंगे। उसके लिए बहुत सारे एग्जांपल्स हैं। जैसे ये एग्जांपल दे रखा है मैंने। अब यहाँ पे देखो कि मैंने ये पाथ चूज कर लिया, y इज इक्वल टू एम एक्स। ये स्ट्रेट लाइन होगा, m को कुछ भी ले लो, m जो है वो स्लोप है स्ट्रेट लाइन का। अब इसको जब सब्स्टिट्यूट करके लिमिट निकालेंगे इस पाथ के अलोंग, तो ये इतना आ गया। ये किस पे डिपेंड कर रहा है? m पे। तो अगर पाथ हम चेंज करते जाएं, m का वैल्यू अगर चेंज करते जाएं, स्लोप जो है वो चेंज होता जाएगा। अगर m इज इक्वल टू 1 लें तो लिमिट आ गया 1/2। m इज इक्वल टू 3 लें, मतलब अगर हम m इज इक्वल टू 1 लेंगे तो कौन से पाथ से आ रहे हैं? y इज इक्वल टू x से। m इज इक्वल टू 2 लेंगे तो कौन से पाथ से आ रहे हैं? y इज इक्वल टू 2x से। तो y इज इक्वल टू x से आ रहे हैं तो लिमिट आ रहा है 1/2। y इज इक्वल टू 2x से आ रहे हैं तो लिमिट आ रहा है 2/2।
Okay, hello class.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir.
sir.
All people are in the class.
Yes, sir. I think we can start.
Okay, give me 1 minute.
Sir, your voice is echoing.
What happened?
Nothing, sir. Your voice was echoing before it.
I think now it's okay. Okay. So now there are how many students in the class right now? Seems to be 57. So I'm giving little talk on this cold atom for quantum technologies. And nowadays, quantum technology is a big field all around the globe. Not only abroad, now Indian government also has started initiative to use the quantum technology, and there are many ways of doing this thing. So I will be giving talk how we are going to give the using the cold atoms for this, and during this talk I will try my best not to use any mathematics that you cannot digest. So I will try to keep as much as simple, and so that whenever you have a question, you can always ask me. Okay?
सर आज आप क्वांटम एंटेंगलमेंट के बारे में बताएंगे?
Quantum entanglement, so next maybe next class I can tell, because I am not going to tell in this thing, because before that you have to understand superposition, then before that many things are there. So I will just give the idea. Main purpose of this talk to give the idea how people are using it. Because atoms are not trapped, then how can you do the entanglement? First you have to trap the atom. Okay. So here I'm just showing one picture. I have taken from magazine, showing some. This is some. Yes.
Sir, can you please record the class for future reference?
There is no future. I'm just giving a talk, and next this weekend I will also take the exam. Okay. Very simple talk. And there is no need to problem. I will share the slides. That's all. Okay. So I am showing here in this picture, this red color is some beams, laser beams are going on. There are this green color, you can see the coil, some magnetic field we are generating. In the center we have a zero magnetic field. So I will discuss all this thing in coming slide also. So here I am writing particle interferometry with the ever bigger and more complex object. So you must have seen this one simple equation, de Broglie wavelength, lambda is equal to h over mb, and I am sure all of you know, because this is in your class 12 book. So here h, what is h?
Planck's constant.
Very good. M is the mass of the particle, and b is the velocity. So first I will discuss with the m, then we'll see what will happen with the v. So very famous equation. So here I'm just showing some particle, for example, photon, it has a zero mass. Electron, I'm writing all this mass in terms of proton mass. Electron mass, it was discovered 1950, neutron, atoms, and so on. So if we are going to substitute, and this I'm showing the big buckyballs, I'm showing very heavy molecules. They have very more bigger mass. So if you substitute the value of these mass in this wavelength, to find out the wavelength, we are putting the mass here. So you see, when it's a less mass, we understand that lambda will be higher. As m will increase, lambda is going to be smaller and smaller. The same thing I am trying to show here. It's not in scale, just to graphical, my these cartoon pictures are there. Okay. As mass is increasing, wavelength is reducing. And then we have to make the atom cold. That is, I'm saying here, quantum frontiers. So when we have to, how to make the atom cold, and what is the meaning of this atom is cold or not? So simple thing, as atom become cold, it means its velocity become less. So I'm again going to show you this de Broglie wavelength equation. So basically, our main purpose is this: we have to reduce this V. When we reduce the V, you can again make out from here that lambda is going to be increased. So let us say any particular gas, some helium, nitrogen, whatever we want to take, we take and we start reducing the velocity. As we start reducing the velocity, we will find lambda is increasing. The same thing I am trying to show here. So in a room, or let us say in some experiment, we are taking one gas. So generally, mostly in the lab experiment, we take sodium, cesium, rubidium. Some gas form has been taken. The main thing is that making cold means we are reducing their velocity. We have to reduce the velocity very low. Zero we cannot reach, but we can reach very low. So temperature basically is a random jingle I'm saying here. And then thermal velocity, I'm going to compare temperature when reducing, thermal velocity will reduce. What happened to de Broglie wavelength? So I'm showing here when atoms are hot, thermal velocities are very fast, I'm saying. So de Broglie wavelength, you can see it very small. The moment we make it cold, thermal velocity will slow down. So de Broglie wavelength will increase if you compare with this formula. Because as the B reduce, the lambda will start increasing. The same thing I have shown here. I think all of you will agree with this.
Yes,
All of
sir.
you agree? As we
Yes,
reduce
sir.
the
Yes.
velocity, so it is going to reduce. Okay. So we are going to get the big de Broglie wavelength. So how cold is cold? Question is this. I'm saying. So temperature, I'm just showing, suppose when you have to measure the temperature to make sure this is cold or not. I'm just showing you one thermometer. And in this thermometer, I'm showing the root gauge temperature. This side I'm taking Kelvin, this side degree. This is just normal temperature, not right now temperature. Some temperature, 33 temperature in Roorkee. Okay. And then, say I said absolute Kelvin we are taking, I'm showing here. And Celsius temperature I'm showing this side. And just I'm dividing temperature here. Let us say 200, 100, and 0 degree I'm showing here. Okay. So again I've divided here. 100. I have come here 250. You can say 150, 50, and 0. So if we start reducing temperature, if you go to Srinagar right now, recently -6 degree, -8 degree in Gulmarg temperature was there, somewhere here. If you go Atlantica, more lower temperature, this side. If you go more down, air liquefies, more low temperature here. And this is outer space, you go some Tinton, some, I think, planet is there, temperature this much. And here, outer space temperature will reach totally 3K. There will be reaching almost very low temperature, 3 Kelvin I am saying, but we are not reaching 0 degree. Okay. So absolute zero, it means all motions stops. Okay. Now I'm showing here the rubidium atom. So rubidium atom, you will listen from me many times because I am working on this atom. Main purpose of this atom, we are going to make quantum gates in the future, whatever this thing. So right now I'm just giving you a simple talk. So here I'm just comparing, suppose you have how much temperature, what will be thermal velocity, and how will be corresponding wavelength. So if I'm in the room temperature, let us say 300 Kelvin, so this rubidium has a velocity 300 meter per second. If you calculate the de Broglie wavelength, so we will get this thing near about this. And if I reduce the more temperature up to here, 300 millikelvin, then corresponding velocity will be this. Then corresponding wavelength will be this. This is micron I'm talking here. If I go more temperature lower, so we are reaching 1 centimeter per second thermal velocity. And corresponding wavelength will be around, de Broglie wavelength will be 1 micron. And people have reached up to picokelvin also. But problem with this picokelvin, due to this Heisenberg uncertainty principle, then we cannot make out where is the atom is. You cool down so much, so you must have read, if you have, someone of you have read the little more physics, delta P, delta X, which corresponds to H. If you making by you, some of you are disturbing the class. If I think if you are and you understand you are very intelligent, so you can leave the class. I have no problem. So if we reduce the velocity too much, it means momentum will reduce very much, but there will be uncertainty in the position of the finding where the atom is there. So we cannot make sure where is atom in the space. Atom is here or atom is there. We cannot make out. So people have reached up to the picokelvin. This MIT group, they showed, but they could not make sure where the exactly right now atom is there. That you must have read. You can take any book, either Feynman book or somewhere you can read uncertainty, this Heisenberg uncertainty. So you can make out from there. Though if delta P, you fix it, so there will delta X. If suppose this is reaching 0, so there will be a lot of uncertainty in delta X. It means you cannot make out where the atom is exactly. So let us go further. So we have to reach 1 nanokelvin, means up to this temperature that I'm talking here. And many groups are doing nowadays of this thing, but most of the groups are working within 100 to 200 nanokelvin, and that is more than enough to do many experiments. So what type of experiments they are doing, this thing that I will discuss in the coming slides. So this Bose-Einstein condensation, in the short form we say it BEC. Okay. Have you heard anyone this name?
Yes, sir.
Yes,
State of a
yes,
matter with plasma.
Yes.
Yes. So
Plasma
plasma is very
Plasma.
hot. Plasma we cannot do. We have to very low temperature. So Bose is a Indian guy. Einstein, you already German guy. You already know. Extraordinary. And Indian contribution is also from there. Satyendranath Bose. So I just give the little history, what he did, what Einstein did, that I am telling here. So this happened in 1924, almost 100 years back. So Einstein, basically he did some work and he sent to the Einstein. He was a very shy major guy. So Einstein translated a paper of S. N. Bose which contained a new derivation of Planck radiation law. based on statistical treatment of photons. Okay. And then later on, he used this idea, Einstein, and he worked around this, after this paper, he worked in 1924 to 1925. Einstein presented a similar treatment for an ideal gas of indistinguishable particle. At some conference name is there, a German conference. So you can make out some German word. So he presented this paper there in this conference. And what was that? That thing that I will show you in the coming slide. So later on, that was the history. And work from 1925 to 1980, nothing happened. Just remember, if any theory come in the, we do some theory, we do some experiment. If theory is there should be experiment. If there is experiment, there should be a theory. For example, when interference experiment happened, so Young's did it. So he found when light, very famous statement, given light meets light, there is a dark. But he made theory also. You people have read interference experiment. Why dark is there? Why bright fringes are there? So he did experiment. He did the theory. Here theory was given, but in between people tried. From 1925 to 1980, people kept on trying. There should be, we should get the Bose-Einstein condensation. But limitation were at it from this time 1925 to 1980, we had not very nice instrument to make the vacuum. We did not have a very nice laser system, because whatever I'm going to discuss in the coming slide, old atoms were made using the laser light. Even we say laser beam is hot, it cuts the material, but it will also make the atoms cool. How? That I will discuss in the coming slides. So laser cooling in between, and just I'm showing some famous people who got the Nobel Prize. So I'm showing here Todor Hensch, Shallow. He got they worked on some neutral atom initially. They gave idea. They got Nobel Prize in 1981, and Hensch got it in 2005, and so on. Some work were done on the ions. So Delmelt and this Wineland, they in 2012, 1989. And 1997, then laser cooling, they got people, Steven Chu, Kohn Tanuji, and I'm just forgetting his name. And this is Eric Connell, Cutterley, Wyman, all this 2001. Atomic BEC made. So 1924 work started. Cooling happened in 1997. Cooling happened little before, but Nobel Prize was given here. I think by 1985, cooling was done. It took many years. But Nobel Prize was given because when their application started coming, on that basis they got the this Nobel Prize. Okay, so I'm coming to the more details to understand the BEC, Bose-Einstein condensation. So this is the coldest matter in the universe, because we have to make the atom very cool. What is temperature? Question comes, what is temperature? This is a measure of energy. The more temperature, it means it has more energy. If a low temperature, it's a less energy. Simple logic, you can also say. So motion, suppose anything going, basically that is also energy. Anything moving, that you already know. The question is, what is temperature? A measure of energy. Zero temperature means zero energy. Just think in terms of the atom. Atom is moving in a free space. It's moving, it depends upon the outer temperature. And if it stops, it means it has no energy, it means it has no temperature. So how cold it is in our laboratories? So I said Nano Kelvin people have already reached. More than 1 million times colder than interstellar space. So much cold temperature has been developed in the laboratory. Many laboratories all around the world, not only in the world, even in India, many laboratories. So what happened to atom at low temperature? So we will understand this. They slow down from 300 millimeter per second. They reach to the 1 centimeter per second. That much temperature reduce. Even we can go more lower than this. So once this happen, all the atoms they behave in the same way. So that's why I have written here. They march in a lockstep. All the atoms they behave in the same way. Okay. So I'm just showing this paper published in Science. It was 1995 BC was made by Eric Cornell and group. They are showing this particular, you can see here, some atoms they are showing they are marching in a lock. So what is a marching in log that I will show you in the coming slide. It will like more and more I will compare, then things will be clear to you people. Okay. So cooling a gas of atoms. So I'm just showing here in this picture, atoms are going some this direction, that direction, this thing. And temperature is, so here you can see 1 millikelvin of the range is either 10, 100, so that range within some temperature is here. The atoms are going randomly in all direction and they have a velocity almost just like an aeroplane. What is aeroplane velocity, by the way? Anyone can guess in kilometer per hour? Bolo bhai.
800 to 1000.
6 to 700. 6 to 700.
So it is less than sound speed, that is for sure.
That of course. So that is fighter planes. They go to by 2 Mach, 3 Mach, 3, 4 Mach. We say na ki if they are twice of sound speed, 2 Mach, 4 times of sound speed, we say it 4 Mach. You must have read MACH. These are our fighter planes.
Yes.
Okay. So then we reduce the temperature. So I'm showing here some of the atom velocity start reducing when temperature is thing, and more reduce. Then as the temperature reducing to deep wavelength, the corresponding wavelength start coming. That I'm showing here in this figure. So what happened? That you already know, given by I showed the Louis de Broglie, he also got the Nobel Prize in 1929. And I don't know whether you heard or not. He published his PhD thesis. I heard it is only 4 or 5 pages thesis. That's all. 4 or 5 pages. And then we reduce more temperature. I'm coming here. You can see almost 10 microkelvin somewhere. Then atoms are moving just like a snail. I'm showing here. It was a plane. Now we reach to the snail. But as we reducing the temperature, you can see de Broglie wavelength size increasing. And we reduce more, then it become more bigger. And what happened during that time? Many atoms they behave such a that their wavelength, the de Broglie wavelength, they start overlapping. So they start going to the bottom of their system. What is the bottom of the system? That I will discuss in the coming slide. Because initially I'm trying to make my lecture as much as simple and smooth, you people should understand. So this is I'm showing here whatever discussed by the whatever discussed by the Bose and Einstein. Atoms are described by the same quantum wave. So all the atoms to go to the lowest of the system. So let us say one system is there. Suppose if I am saying this is a bucket, they all reach here. But this is not a bucket. If any one of you have read harmonic oscillator, we try to make a harmonic oscillator and they reach all the atoms in the ground state of the harmonic oscillator. And then they behave as a giant wave because all of them have the same phase, same log, as I showed log, and they behave in the same way. So just remember right now. And we are very low temperature at that time. So all these things, whatever I was telling here till now, I have summarized everything. When temperature was very high, thermal velocity, density proportional to the 1 over d cube. This I'm showing d here. As we start reducing the temperature, why my slides are jumping. As we start reducing the temperature, then de Broglie wavelength start increasing. And I showed de Broglie wavelength is equal to h over mb, or we can say 1 over t, basically. At some critical temperature, this de Broglie wavelength and d, separation between the two atoms, they become equal. The matter wave start overlapping. We get at some critical temperature, the Vc, and when temperature is T equal to 0, at that time we get the pure BEC. At that time we are saying giant matter waves. So this matter wave is overlapping and giant matter waves. But BC start at some critical temperature. In that I'm saying is no need to go to at T equal to 0 just before it start coming. Obviously, as I'm saying, when T is equal to 0, but T is equal to 0 is an ideal condition that never happen in the, we will never reach. I said people reach nano Kelvin, they reach pico Kelvin. But T equal to 0 is ideal condition. I think all of you will agree because T is equal to 0 is not so easy thing. Because there is noise always in the nature. So any question up to here?
So this critical temperature is absolute or relative, like whether it depends on different like nature of different atoms or not?
So see, when people started working initially, I'm talking again around 1985, people were working rubidium, sodium, cesium, many things were there because they are all alkali atom. They have a single electron in outer shell. Plus also depend because when we are doing this experiment, we need a corresponding lasers. With the same laser, you cannot work with rubidium. Rubidium has a different wavelength. Sodium has a different. Cesium has different. Lithium. At that time, people started. Nowadays, people are working many more atoms. Even they had reached to the ytterbium, strontium, and I will tell you all this thing in coming slide because why people are jumping here. And for example, I am working on rubidium. Whatever I am working, because I will be using rubidium atom to make the quantum gates. Whatever quantum computing gates, I am working on it. It depends upon how much facilities you have, because these experiments are very expensive. You will be working around 10 to the power minus 12 torr vacuum. 1 torr means 1 mm corresponding to 1 mm Hg pressure. You need a very good vacuum, then corresponding laser. Laser should be very ultra stable. Their frequency should be fixed. They should not go left and right, and lot of electronics. Because in present in this century, everything become very sophisticated. We are just working engineering, all these engineering cutting edge experiments are going on all around the world. So you have to be perfect in everything. That Raman age has gone. Raman did very simple experiment and gave very nice theory and everything. Got the Nobel Prize, one and only one in India so far. But nowadays, everything has become very sophisticated. And I'm sure most of you will take these things in the future. Okay.
Sir.
Yes.
Sir, means that means that Bones Einstein condensate that theorized that there would be a giant matter wave at t is equal to 0.
Yeah.
So, but there is no any kind of experimental evidence, right?
No, I said a nano Kelvin, pico Kelvin we have reached, na.
But
PEC already made.
Equal to
People
0.
got the Nobel Prize.
Yes, sir.
PEC is already made. I should go back. The people have already got the Nobel Prize for this also. I go back 1 minute.
But sir, that is for pico Kelvin and nano Kelvin.
No, nano Kelvin enough. They are able to show all the feature of the PEC.
But like, yes. Sir, can they be like virtual particles which pop out from the space time and then again they means disappear? Something like that can happen or what?
No. They did. They got it. Whatever the theoretical model says, ki what is the feature of the BC, they showed everything.
Means I'm talking about absolute zero. I'm not talking
about. Absolute zero. See, that depend upon what you are doing in these experiment against the nature, because nature doesn't provide you 10 to power minus 12 torr vacuum. These are very ultra. This experiment to be cannot reach T equal to T0 is equal to a ideal condition. We are fixed. But before going to, if you are going to micro Kelvin, nano Kelvin, pico Kelvin, you cannot reach. Our measurement tool is also very perfect, na? Because atom stops. It is difficult. If you go in even in a vacuum, you have hold the atom, you cannot say you have hold. Because even your laser you are using, data has also some jittering. It is not as fixed. That is also jittering. That frequency also has some jittering. Even if you do the jittering, so still that atom will be oscillating. Very small oscillation will be there. So that will give the temperature. Just if we are saying if we are holding the atom, but our measurement tools also become a very sophisticated. They are able to measure the temperature. Have you got my point?
Sir, like, can't we consider them like they would become a virtual particle and then they would disappear? Like this also it can be happen.
No. How will they disappear? Where can they disappear? They are there.
It's like virtual particles, sir.
Virtual particle means virtual though, but atom is there. How can it disappear?
Means like that Hawking radiation, he proposed that there would be like a virtual particle would pop out and one would come out of the black hole, one would sink in the black hole.
So like that's why those theory finished. Suppose any experiment you are doing, there should be any theory, there should be a, that is the only whatever talking, that is a statement, but nobody has done experiment on it. Whatever I'm talking, this is real experiments.
It means we don't have
whenever any theory proposed, there should be a evidence proof. I'm talking about the proof is there. People have done the experiment, they have measured it.
Okay, sir. Okay.
That's why, see, a lot of theories comes, but whenever there is no experimental proof, they always disappear. Any theory, if supported by the experiment, then they move forward. Just remember. And whenever any experiment comes, there should be always a theoretical proof.
Okay, sir.
Sir,
yes.
How can we measure such nano Kelvin temperatures?
That is a good question, very good question. So I tell you. Anyway, I will show you in the coming slide, but right now I can tell. See what we do is, suppose we have atom here, okay, and we put the light, laser light, and we do the imaging on the CCT camera. Not a very simple CCD camera. Whatever I am using, we call it EM, electron multiplier CCD camera. Even single photon comes, it can detect. So we take the images. Suppose I take one image at let us say 0 second. Let me, I should not say at time t is equal to 0, and then I take another image at t equal to 20 second. How much separation between them? Suppose atom was here, and then we know the separation, and then we can find out what is the velocity. Well, not velocity. What is the distance from this distance to this distance? It has been in 2 seconds, and then we can measure it. What is the velocity? And from velocity we can find out the temperature, because we cannot measure by any probe. We are using we cannot touch it from outside. Suppose anything is in a vacuum, atom is in the vacuum, we don't have any tool to touch it. We are just doing all things using only laser beams, putting from outside and then doing the imaging on the CCD camera. And then we have to find out the position here, time, separation, and all these things.
Sir, how do we know that the same atom has moved? It can.
This is not a one single atom right now. Let us say we have a 10 to the power 14 atom. Let 10 to the power 4 atoms. 4 to 5 atoms. They will be in a group. It will be in the laser. We are holding with the laser beam. Let us say this is a laser beam. We am holding atom here. And you switch off the laser beam. The moment you switch off the laser beam, this atom will start falling due to the gravitational force, and their area will start increasing. Whatever was here and whatever here, separation difference is there. From there we estimate how much has changed in the dimension. From there we get the what is the temperature.
Okay, sir.
Okay, because you can, if you touch anything from outside, then it will be not a quantum world. Quantum world, you don't have to touch from outside. And whatever this VC I'm talking, it's a quantum gas. We reach to the quantum world. It's no more classical world. Okay, so T equal to 0, I said this is the ideal case. But nano Kelvin is more than enough to do many experiments. Okay. So what is the goal? I'm showing here goal, main goal. Use ultra cold atoms and quantum gases. Quantum gases means BEC. To gain fundamental insight into quantum mechanics to build the quantum devices. So fundamental insights to understand the quantum material. So here I'm showing one magnet is levitating. And we can also make a atomic clocks, quantum devices. So these atomic clocks, very sophisticated. And if you use them in 5,000 years, only 1 second will change. That much of sophistication is there. I will also come one by one these things. So many body system, superconductor I'm talking here. So here, if you see inside, they are inside this I'm showing you there a pair of electrons. Here I'm just showing a pair. So intricate quantum motion of electron gave rise amazing microscopic behavior that we want to understand. But thing is that and normal, if you take magnet, it's very complicated, complex structure. But to understand, we can take some pure gas, let us say rubidium, cesium, whatever, and we can make a pairing there. People are already made the pair between the two atoms, and they have done the study. Basically, you can say artificial matter has been made in the laboratory, pure artificial, and then you study them. Already going on around the world. If you want to know, I can let you know. Then simulation of classical computer. So memory requirements for n spin half particles I'm showing here. In classical computer, I'm just showing there n bits describe state of the system. So here I'm showing some up, down, I'm showing here. But in the classical computer, in the quantum computer, things comes like this. Suppose here we have taken 1, 2, 3, 4, 5, 6, 7, 8. Here I'm so 1, 2, 3, 4, 5, 6, 7, 8. 8. I have taken the electron. Here one's on all up, then one down, and the one this down, and so on. We can make superposition of so many states that I am showing here. So basically, I am showing here 2 to the power n complex number alpha I describe the state of the system. So many, just by using the 8 spins, we can make 2 to the power 8 states to describe a system. So already work is going on all around the world. I'm just showing you most powerful computer in the world. Fukaju leak in Japan. So you can see some numbers are written. 30 MW, 500 petals, 480 petabytes RAM. You know what is petabytes? How much? GB? 1 petabyte is 10, maybe 1 million.
Sir, 10.
1 million gigabytes. 10 to the power 6. मेरे computer में my computer here only 32 GB. And see what they are using. And if we want to make such a powerful computer, we need only 56 spin of 56 atoms. If we use 56 atom or 56 superkinetic qubits, whatever Google and IBMs are using right now, that can make such a powerful computer. Just compare where we are reaching now. Okay, a few more. I would like to give you a few things more. The ultimate supercomputer I'm showing here ki store one complex number in each atom. Suppose store one complex number in each atom, then you need 10 to the power 80 atoms in the visible universe. In the visible universe, we say there are so many atoms are there. And here why I'm giving it, just to compare. If we take 270 spins or 270 atoms, that can store that much information. The difficulty lies in entanglement of the system that people are working nowadays. Once we get very nice entanglement, so we can do so many things that nobody can imagine. The solution to use quantum. 1 minute. The solution is use quantum computer, but we neither have a good quantum computer right now nor a good quantum algorithm. So many groups are working right now around the world, me also. So have you understood what I have said up to now here?
Yes, sir.
Yes, sir.
Yes, sir.
सर इसमें चाइना आ गया है ना सर हमसे? सर चाइना को अचीवमेंट रीड किया था मैंने सर कुछ दिन पहले.
क्या चाइना हम लोग से आज बहुत पहले से आगे यार. हम लोग टीम वर्क नहीं में फुसटी हैं इंडियंस लोग. We are not good team work when it comes to the team work management. We are not good.
सर मतलब मैंने रीड किया था कि उन्होंने क्वांटम एंटेंगलमेंट किया था, मतलब काफी हाइट से.
ऑलरेडी हो चुका, नहीं ऑलरेडी कर चुके हैं. चाइना से पहले यूरोप में भी हो चुका था. already China is good only because they send this entangled photon in the space that is up to 4,600 kilometer. So cryptic information can be sent from one place to other place. Indians also did, but later on we have also done. Our ISRO group has done already. And thing is that we are a little behind. Problem is this. So you can check, lot of work is going on. Even if you search quantum technologies, you will write down Indian government, you will also find what is going on in India. But the only thing is that in India, this work started only 3 years back. Okay, then go further. So immediate solution, quantum simulation. We are also doing quantum simulation. Quantum simulation, we are just now, I use one word, artificial matter. We are making artificial matter using these cold atoms. Use well-controlled quantum system to simulate difficulties to access the quantum system of interest. So basically, this state, first time this thing was given by the Feynman. Maybe in the next lecture, I will show you. Even I will show you if I would take the two-level atom and we just do the simple modeling of this, and I will show you this is nothing. It's just like a quantum gates that we use in the quantum computer. That I will show in the next lecture. Okay. So this I'm showing here some atomic. This is the clock we are making actually. So this is my last slide because almost lecture is finishing. So basically I'm showing the quantum model. Basically I'm showing it when we are doing the things, we have to write Hamiltonian. I don't know whether you people have heard the word Hamiltonian or not. Don't worry. Basically this is the energy, kinetic energy, potential energy you add something like a Hamiltonian. So to theoretically I'm talking, and then quantum simulator, whatever I'm showing here, we trap the atoms. This is I'm showing is of each atom trapped in a uniform way. I mean, we can make whatever we nowadays atom can be trapped in whatever way you want to trap. We can trap it. We have reached up to that sophistication in last 2-3 years. So you just put in order all the atoms. Here I am showing in the 2D, you can put in 3D also, and then you do all the other studies. In interaction between the two atoms, many atoms, we can do everything. So this is called simulation. So theoretical concepts are clear. So here I am showing we trap the atom, whatever I am showing here, trap the atom, then interaction between them. We can control the inner state, whichever state we want to put the atom inside, we can also put. That we can do right now, everything. So for all this purpose, we need a ultra cold atom. The atom should be controlled by us only from outside. So as I said, just a few slides back, we will be using this thing to understand the quantum mechanics and quantum devices. So quantum devices, basically mainly quantum clock, atomic clock I should say. So by atomic clock, see pendulum, you already know, used many years, 15th century, 16th century, 17th century, and now we are on the atoms. So I just would like to show why we are doing this thing. Okay, to get the high accuracy, high tension frequency. So for that, it depends upon the optical tension, then narrow tension. It has a line width of the whatever line width means when we are plotting frequency versus in basically frequency, this frequency, tension frequency, let us say center frequency omega naught, that is of the order of megahertz, very narrow. Even we have gone less than hertz, you can make out from here. Millihertz, it means we are less than 1000 of down from the 1 hertz. Last signal we use many atoms, then disturbed by the other atoms, to use gas atoms, because gas atoms a little far, so they don't neutral atoms, they don't interact with each other, so much better than compared to the ions. Initially people were making the atomic clock using the ions, now but we have found neutral atoms are much better. And observe for a long time cool atom to stand still, but I said we cannot reach to the stand still, but we reach almost zero, but not zero. So that I said, one group in the US, they have trapped the strontium atom like this and putting the laser beam there, and they are using this optical frequency comb. But basically, in the broad way, I would like to say, they have made the atomic clock, and as I said, it in 5,000 years, I said 1 second, not 1 second, even less than 1 second, change will be there. That much accurate atomic clock has been made. Achha, now I just stop here. Do you know why you are working on the atomic clock? Can you tell? Anyone who has read?
To demonstrate
to reduce the time dilation effects that we observe because of the motion.
You are right, right. But just for example, think like this. You heard about the GPS?
Yes, sir.
Global Positioning System. We have many satellites, around 16, 17 satellites. All of them have to be synchronized at the same time for better and better accuracy. Suppose you want to fire the bomb somewhere, even your if a laser guided missile goes, they are controlling with the GPS. Even you have mobile in your hand. Okay, so you can make out where you're standing. This is not happening only due to one satellite. 4, 5 satellites participate in to find out the accurate position. Where are you standing right now? Okay. So I will come. Let us see how much I can finish. And right now today, whatever I've told, we are reducing the temperature of the atom to use them for quantum computing and quantum simulation. I'm not going in very depth. I'm not telling me. I'm avoiding a question till now, except at de Broglie wavelength. So whatever I have taught, and next week, not next week, this is within this week. I think Friday I have a class 5 to 6. I will take a one quiz. There will be 2 questions, and you have to send the answer in 10-15 minutes. And that will be, I will be grading from there. I will not take any exam later on because you will forget. So be there in the class next time also.
Thank you,
if you have any question, ask me.
Will you share the slides?
Yeah, I will share. So who is the, okay, I will keep there today, whatever I have finished till today. You will find the PDF file there.
Sir, I have a particular question about quantum entanglement.
Please ask.
Yes, sir. Sir, consider that somehow we manage to entangle 2 particles like 2 electrons, and then we take 2 Stern-Garlick apparatus. Then what we do is that in that apparatus, the magnetic field is way too high. So that what happens when we measure and apply the magnetic field, then simultaneously what happens, the spin of the particle changes. Means the measurement, the change in the spin takes place simultaneously. Okay, so when we allow one of the electron to pass through the Stern-Garlick apparatus, then will the other also change?
By Stern-Garlick experiment, whatever I know, let me tell, they are using something, some magnet here to make a inhomogeneous magnetic field. It's like they were passing through the silver atom. They got some spins like this. So spin like this, and they said this is a up and this is a down.
Yes, sir.
Okay. And for example, I am working in the rubidium atom. Now let me compare. So in rubidium atom, I take two atoms. This is the ground state. This is the excited state. This is the ground state. This is the excited state. And I say entanglement is 1 over under root 2 Eg plus Ge if I take the symmetric state. And in this case, whatever you're saying, if I am right, you will be
Yes, sir.
yes, man. Now see here.
Evening to all of you.
Good evening, sir.
Good evening. So we enjoyed
Good evening, sir.
something by Mohit.
Definitely,
Okay, so
sir.
fine friends, people are still connecting, I guess. As informed, some people may be busy in some other class. So
Yes, sir. The last class is not finished.
joining us. And I've been informed by Professor Smita Jha, the coordinator, that this arrangement of combining R and S batches will continue. Okay. So students from R batch will also join us for this class regularly. When I added them in the last class, I thought that it is just a one time arrangement, but now I have been told that this will go on. So no issue. Is in online classes, it's quite flexible actually. So last Friday I was on leave, and so we could not connect for the class. And since we are lagging behind as far as the syllabus coverage is concerned, so I thought of asking for this class. Again, let me ask if any other time is suitable for you, more suitable for you, compared to Friday 8 to 9. We can permanently shift our class to that. I mean,
yes, sir, we should shift, sir.
I don't have any difficulty in engaging your class 8 to 9.
Yes, sir, we should shift.
You should shift, sir.
Sir, at which day?
You can suggest me some time.
Sir, the CRs would discuss it, and then we'll just
yeah, sir, we will
give forward
commit,
the day and time.
Sir, but right now, a lot of people from my batch, our batches, they are trying to join the class, but they send a request to join the team, but the request has not been accepted. Can you please accept the requests?
No, I'm accepting all the requests that I'm getting.
Okay.
So just now I got from Ayush Dhiman and couple of other people.
Yes.
No, whenever I get a request, I immediately accept that. Okay.
Okay, sir.
So why do we only have 240, 50 odd people when I expect more? Because, you know, originally 180 odd people were there in S batch alone. And then in R batch also, we have a strength of 92 officially. So that means our total strength should go up to 278 or 280. So I believe the entire R batch has joined us. in this team? Do we have only one CR in entire R batch, or you have?
No, sir, I have a co-CR, Shreyans Tiwari.
Yeah.
Yes, sir. I'm messaging everyone on the group to join the team.
Please.
I've given like reminders before.
Tell them that this will be their regular class.
Okay.
Okay.
Okay, sir.
Yeah, yeah. So just now I got it from Piyush Garg, so I have accepted that. So whatever requests are coming, I am joining them on a regular basis. So let them send their requests. Okay, friends, so should we start now? Because we have already waited for 10 minutes and people will join us in the process, but let's go ahead. We already have 210 people attending this. Okay, so I'll take forward the discussion that we have started. So if you recall, we are discussing process and barriers. So process I had to repeat because the RBAS friends had missed the earlier classes. So I repeated that for their benefit, and that is how we are somewhat lagging behind, but don't mind, we'll just pick it up. So in the last class, friends, I was asking you if you know the barriers that hinder the smooth process of communication, and I was very happy to note that most of you came up with valid answers. So what I'm going to do right now is I'm just going to talk about that a little bit in a systematic fashion. So generally, we all know that communication is a complex process involving two parties, and as such, there is no guarantee that each time we communicate, the communication will have 100% result. And this is because of so many internal and external factors, so many factors that are not within our control. However, if we increase our awareness of the process of communication, many of these barriers can be controlled, can be taken care of. So first of all, let me talk about the common barriers. Well, friends, when we talk about communication, it happens in an imaginary frame, and that frame may be termed the frame of reference. Now, what is this common frame of reference? Is that the moment two people agree to communicate with each other, they enter a common frame of reference in which they agree to talk in a common language about something which is of common interest. So right now, the common frame of reference for us is that we are discussing communication and we are talking in English language, which is the medium of communication for us. So there is a consensus or an agreement, although we have not, entered into any kind of formal agreement, but still the moment you join this class and I start engaging this class, it is understood that we both agree to share something related to communication in this class. Okay, so this is going on. My slides are visible to you?
Yes,
Are my slides visible?
Yes,
Yes,
sir.
sir.
Yes. So supposing if there is no common frame of reference, supposing somebody else has joined this class who is not aware that this class has been assigned for discussion on communication skills, and who is the teacher, what is the context. If somebody has joined and does not know all these things, then this will prove a barrier in communication, because the other person will not be able to relate to whatever we have been discussing. The second barrier of this type may be arising because of badly encoded messages. So sometimes when we are writing something to somebody, maybe we are using wrong words, maybe we are using wrong grammar, and as a result, the other person may not be able to get the intended message. So badly encoded messages also prove barriers. Then again, I'm talking to you people believing that I'm audible to everybody. But if somebody is having some problem with his or her transmission channel, then also he or she will not be able to listen to me properly. So disturbance in the transmission channel might also hinder the process. Poor retention, how does it prove to be a barrier? What happens, you confide in some friend, or you share some knowledge with some friend, and the friend has a very poor retention power, and later on he complains that you never told him that thing. As a result, there will be barrier in your communication. Again, inattention by the receiver. Supposing I'm talking to you, and at the same moment when you have joined the class, you are busy talking to somebody else, or there is a lot of background noise which is not allowing you to pay attention to whatever message is being delivered. So that will also prove to be a barrier. Again, premature evaluation of the message is a kind of barrier. What happens many a time, even before the other person has finished the message, we come to certain conclusions. And mostly these conclusions are not up to mark. They are based on half truth, and as a result, create some confusion or create ill will among the communicators. So premature evaluation of the message is also a kind of barrier. Then unclarified assumptions, when we are talking to somebody and we believe on our own that we have more in common than we actually have, then also barriers arise. For example, I can just tell you one thing, that you talk to some friend about going to some place someday, and the other day you said that you will will a particular time be suitable, without even clarifying what are you talking about. Let's say, what about going to civil lines? You talked about that someday. The friend in between talked about going to some other place someday, and out of blue someday you just said the other day, what about 3 o'clock? Will that be a good time? And your friend could not understand whether you are referring to his proposal or you are referring to your proposal. So such unclarified assumptions are also big barriers to communication. So if you want your communication to be foolproof, each time you communicate with someone with reference to something that has been talked about earlier, you try to make it clear that you are talking about going to civil lines or you are talking about going to the playground. Again, mistrust between the sender and the receiver is a barrier in the sense whenever you deliver a message, the other person will not believe in that. All of you may be aware of that story, bhediya aaya. If you tell 100 lies, even if you tell truth someday, people will not trust you. So trust is also very important, and so mistrust is also one of the barriers because the other person will never believe in whatever you are saying. Then again, each individual is different from the other individuals, so we all have different perceptions of reality. So when I try to explain something according to my own perception, maybe the other person may have some other perception about the same reality, and that way the perceptions will differ and there will be difference in convergence. So that will also create problem. Semantic difficulties, when I'm talking about something in a language or terminology that you don't associate yourself with, then there will be difficulty in understanding and will create some gap in communication. So let's say I'm using a terminology from the field of cricket, sneakometer or hotspot. Somebody who does not follow the game of cricket might not be aware of these terms. And as a result, I may not be able to communicate whatever I want to communicate. Again, if two people are communicating with each other without actually knowing what objectives do they want to achieve, then also the communication will fall into disarray simply because none of you knows what needs to be achieved. So we are not talking about general communication, we're talking about professional communication or technical communication or object oriented communication. Such communications always need to have a clear cut goal or objective. Then again, misinterpretation of the message is also a kind of barrier. So I'm sending a message which you are not able to properly interpret, or you interpret it differently, then also this kind of problem will be there. Then class of attitudinal nuances. So two individuals differ from each other, so they may have different attitudes towards things, and as a result also there will be little convergence or little agreement. And again, selection of a wrong variety of language. When you are talking to people, even in the same language, again there is this kind of problem because the languages have variations. So somebody who lives in Maharashtra speaks a different kind of Hindi with different terminologies or different meaning attached to terminologies, and somebody from Lucknow, even if he or she speaks the same language, may have different variety of that. So let's say if somebody says baju in Mumbai, baju everybody knows is side, but if you talk about baju in western Uttar Pradesh, people will not understand or they will take it differently. So wrong variety of the same language might also result in barrier. Now, to be specific, the other day many of you said that barriers might arise because of the psychology of the communicators. Now, how does psychology dictate our attitude towards things is no secret. Our psychology, refers to the whole cyclical psyche process through which we process knowledge or things around us. So the whole thought process depends on our psychological makeup. Now, it governs our attitude, it governs our approach, it governs our thought process, it governs the way we perceive things, our likes, our dislikes, and everything. So the psychology of the people, to a great extent, determines the way they should accept or reject or deny communication. So we will find that many of us may have some kind of rigidity of thought. Now, rigidity of thought means overlooking the difference of backgrounds. So we might tend to think that whatever I am thinking is the only right way of looking at a particular thing. When we do that, we make a mistake. So let's say you have a happy-go-lucky kind of approach towards life, and you believe that alongside your studies, the extracurricular and co-curricular activities are as important, and life is there to be lived fully. And so you don't, all the time sit in your room with your assignments, with your books, all the time doing serious studies. And there is your roommate who is always busy, always worried about assignments, about his studies, and does not accompany you to all those places where you can enjoy. And you perceive that he is, he is an uninteresting person, or he doesn't have any fun in his life. Now the thing is, you never try to know his circumstances. Maybe you come from a well-off family, and that's why you don't have those hardships in life which your partner may be having. Your partner may be coming from a humble background where the parents may have gone for bank loan to support his studies, and he may be aware of the responsibility he may be having, and because of his humble background he may be pressurized to take his degree and master his subject so that he can secure a good job. So his circumstances of life may have forced him to concentrate on his study more and more, forgetting all about fun side of his life. So rigidity of thought is a psychological barrier, and as a communicator, you should not reach any conclusion without knowing the fact. And again, the other way also, it is not good. Like some people have been conditioned in a particular way. So they believe that anybody who is talking other than their accustomed thought is wrong, and they are not able to take it. So you will come across these people who are hard to convince. Why? Because they are very rigid and you cannot change their attitude. The second kind who have psychological barrier are the people who always believe that they know everything and nobody can really teach them. So they will always say, don't teach me, I already know this. So know it all kind of people are spotted in every office. They are around you, and such people are hard to convince. Such people never learn. Fine? Because they always feel complacent. And this is also a psychological barrier. If you have this kind of attitude, you need to change it. Because unless and until you feel that you have to learn something and you have that ready-made mentality, you will not learn anything. Now, how to identify whether somebody has psychological barrier? You will always find that such people are complaining type. They will always use words like all, always, everybody, none, never, nobody, quite frequently. So you will always find them saying, all are corrupt. They are always targeting me. Everybody is against me. None are listening to me. I have never been given my due. Nobody bothers about me. Now, when people frequently complain like this or make use of these words, you need to understand that they have psychological barriers. Now, if you have to communicate with such people, what you need to do, first of all, to understand the rigidity of thought, you need to be empathetic. Now, empathy, all of us know, is different from sympathy. Sympathy is a superficial act, okay, in which we try to make others feel good about themselves by supporting them. But empathy is a deeper act in which we place ourselves in the place of the other person and then know the cause of the reactions or responses of the other person. So unless and until you put yourself in the place of your friend, you will not understand why your friend is not treating life as fun. Fine? And once you understand the real reason for his reluctance to join you for fun, you will start appreciating your friend. You will start helping him. You will start helping him realize his goal. And once you start doing that, probably the friend is able to come out of his rigidity of thought and starts trusting you and accordingly starts opening up. It also requires a little bit of understanding of human psychology. We need to understand the attitude of people. So if we find that somebody is naturally negative in his approach or attitude, we need to understand that person, try to understand the reasons behind his negativity, and if we can find the reasons, probably we can find the ways to convince that person as well. And most importantly, we always need to understand that the different people come from different backgrounds, and that's why they have different perceptions and points of view. So we must have to acknowledge this difference in background and perceptions while talking to other people. If we start appreciating others' point of view, we'll be able to gain their trust. And once we build trust, it's not a hard nut to crack. So even the hardest of the people, the most callous people, can also be softened, can also be meant to listen to us if we show extra bit of sensitivity and extra bit of care and compassion towards them. So this way you can take care of psychological barriers. Any questions till now? Do you have any questions?
No, sir.
Okay.
No, sir.
Now, friends, most of the communication situations are interpersonal transactions. And in interpersonal transactions, when two people are talking to each other, there are certain things that affect the way we communicate. Mostly our emotional reactions always act as barriers. Why? Because when we are emotionally charged up, our reasoning is always at premium, and we are likely to give emotional reactions that are farther from reasoning. So when we emotionally react, let's say if some friend is angry with you, he or she will not listen to your excuses or your own position. If somebody, is very angry with you for not turning up for his or her birthday the other day, and you are trying to, convince him or her about the reasons that were responsible for you not being able to join him or her, at that point in time the other person will not listen to you. They will simply say, don't tell me this, I'm not going to listen to you. So emotional reactions are, a big hindrance in any communication. The second thing, negative attitude, we have been talking about that. If I have already made up my mind to believe that you are a liar and whatever you are going to say is fake, I will not listen to you and I will not believe in whatever you say. The third thing that might hinder the interpersonal transactions is the wrong timing of message. Now, wrong timing of message can be understood like he may have received the message of a failed contract or failed business transaction. He may have got some bad news. He may have, some rough relationship. I mean, there can be many such reasons. And at that point in time, you go to his chamber and ask for promotion. Now, what will happen? He will kick you out of his room and maybe kick you out of your job. So rather than getting a pay raise, you might even lose your job. So this wrong timing of message can be helped at times, but then there are some moments where you have to be a little more diplomatic, and so you need to present the message in such a way that the wrong timing or right timing does not matter. So what I have realized, whenever we send some proposal to a university outside India, they have a very, sophisticated way of saying no. When we get their no, going through their no also is a very pleasing experience because it is so nicely worded. Okay, so if you are forced to give some message and the timing is not right for you, then probably you can word it so cautiously in such a nice manner that the other person does not feel it bad. Now, it's very interesting if you know how to do that. And even the uninterested people will find it interesting if you know how to do that. Now, if in interpersonal communication you find that somebody is reacting emotionally or has a lot of negative attitude, what do you do? Well, that is no time for you to indulge in the verbal jugglery. So when you find that the other person is not ready to listen to you and is charging all his or her bullets, you maintain your calm composure. Let the other person vent out his or her ire or anger, because once these troubled thoughts are out, the mind is, again in the right frame, and then it cools down, and then that is the time you can start building up confidence measures, and you can use persuasive force to let the other person understand that you are not wrong. But when the tides are high, there is no point trying to swim, because probably you cannot take control. Let it subside, then only try to swim across. And then again, while talking to somebody, always look at his or her mood before delivering a message. If you know how to read the minds of the other people and can learn the art of selecting the best psychological moment for delivering, and you go on, giving messages at the wrong moments, you are likely to miss it out. Now, the organizational networks might also prove real barriers. Why? Because if in an organizational network you have too many transfer stations, what happens? Processing of information by several hands creates lot of problems. Too many transfer stations. Let's say you have to make an inquiry about the scholarships available at IIT Roorkee, and you don't have a designated section for that. You write it to the Dean of Student Welfare, who guides you to write it to the Dean of Academic Affairs. You again go to the Dean of Academic Affairs, who says that you write it to the Chairman, Senate Committee on Scholarships and Fellowships, who again is contacted. In the process, by the time you reach the right person, maybe the deadline for that fellowship is already gone, and you feel at the same time you feel helpless that you are just writing from this table to that table without any. The original message will be distorted beyond recognition. So let's say you have to send some message to the director, and you have been asked to route it through your class teacher, who in turn moves it to the head of the department, who in turn refers the matter to the concerned dean, and then the dean sends it to the director. In the process, what happens? Everybody writes something as remark, and by the time the message reaches the director, the remarks have complicated the message, or maybe their remarks have changed the meaning of the communication altogether. So you see, such kind of organizational networks create a confusing situation, and the remedy is the organizations should devise a communication mechanism which has direct access from top to bottom, where you can send your message directly to the person who is responsible to take decision. So you can send your emails to the director directly. And again, the dissemination of information through several hands in the sense you don't have to process to that the original message will reach the concerned person, and you don't have to worry about that, because if you write to anybody, that person will send it to the next station and automatically it will go to its destination. And the organization should establish a feedback system involving more than one source. Why? Because if there is only one source, there is likelihood that some person who is responsible for receiving the message, if he or she has a malified intention, he or she might hide information. But if the same information reaches 2-3 different stations, then it is less likely, because all the people might not go corrupt at the same time. And again, if all of them are trying to hide something, then also whatever is common in all the 3 or 4 messages is the only original message, and rest are concoctions that is not difficult to understand. So organizational network should be transparent and should have lesser number of transfer stations, and should establish a system where things are centralized. So I can just give you one example how our communication Dean of Infrastructure IT Roorkee. Now, Dean Infrastructure is responsible for all the building related and all the construction and maintenance related activities on campus. Now, earlier we had different sections devoted to water supply, electricity, civil complaints, and other complaints. At least we had 3-4 different offices. Now, what will happen at times, I'm just giving you one simple example. Once the cistern of my flush was not working, and I called somebody from water supply. The fellow came and he said, sir, this comes under civil, not water supply. And he left. And my problem remained there for another day, because I again went to the civil wala who inquired. There was passing of bucks, He said, no, sir, part of it is under water supply and part of it is under us. I'll do this, but rest should be done by them. But of late, what they have done, they have developed a central complaint system, whether they are related to civil or whatever. You don't have to worry about that. You simply tell them that, there is water leakage, or you tell them that there is some civil repair work or something, and they will note it down and pass it on to the relevant section, and then they will come and mend it. So I believe our organization also realized that the communication is not proper, and that is why they developed this centralized complaint system. So this is one example how this organizational barrier may be taken care of. Next, it can be cultural barriers. Friends, we all know that communication is culture specific, because culture is what shapes how we think, how we act, how we react, what meaning do we attach to something. So if in a particular culture, white stands for chastity and purity, black is associated with evil, people will remember these connotations. So if you look at different religions, you will know that certain colors are associated with something. I'm just giving one example. So the system of symbolic beliefs attitudes of a black American. What is true of an Indian? From North India may not be true of the Indian who is from South or from a different culture altogether. So we all have our expectations, we all have our symbolic beliefs, and our attitudes are shaped up by our cultural upbringing, by our cultures. So just you name anything, the dress we wear, the food we eat, the way we do things, we use right hand or left hand, we make swastika or we make some other religious symbols. We attach certain, symbolic belief to some object. Something is considered pious, some number is considered pious. I mean, all these things are again our notions of time, our notions of hierarchy, our notions of power. They are all determined by our cultural upbringing. So let's say this is one reason why we Indians, when we go abroad, we find that our communications are misunderstood, or we find it difficult to communicate with people from other cultures. As such, because there are long queues in India. But outside there are no people. But yeah, 2-3 people were there. I was buying an Euro-rail ticket from Vienna, and so I was in the middle, and there was a lady next to me, and she reached the counter, and I was standing behind her, and in between there was an yellow line. You may have noticed that during your security check in airports also. So it is everywhere written that don't step on this unless the other person has left the counter. So I was awed by the beauty of the surrounding. I was in a different zone because I was traveling a different country. So incidentally, I happened to, put my feet on the yellow line separating myself and the other lady. But still there was a fair gap. Maybe 1 feet gap was already there. But still I found that the lady turned back and frowned at me. She didn't say anything, but she just looked at, the yellow line, and I realized my mistake and stepped back. And then I realized that had it been in India, we could have been pouncing upon each other and still nobody would say, this is my space. You must respect this. So, and again, there was another, instance in which I was standing at a zebra crossing and there was no signage as such. And I was trying to cross the road, and I saw that there is a long queue of, cars, and the cars are, just rushing and gushing in unending row. suddenly I realized that within 30 seconds, cars on both sides came to a standstill. 50 cars lined up on each side. And they were screaming virtually, cross, cross, cross. But I was fearful because of my Indian habit, because here, person who is in car always believes that he is the one who is the rightful owner of the road and will trample the person who will come in front of him or her. So, I realized that and they said that unless you cross, the traffic will not be resumed. So then I crossed and then only the traffic resumed. So I was mentioning this to somebody and they said that, I was very appreciative of this civic sense by these people and the, their respect for the dignity of a pedestrian. And then somebody said, no, everywhere we have fitted, CCTV cameras. And if they don't respect you, and if they cross, they will have to pay a fine of 175 euros. So then I was, amazed to find that. But nonetheless, I mean, the different cultures have developed different kinds of, systems. Again, in India, if somebody says you come on time, people might believe that, let me go at ease, if I'm delayed by 5-10 minutes, that does not make much of a difference. But again, let me tell you, this cultural barrier, this culture may be the culture of an individual, the culture of a family, the culture of a locality, the culture of a community, the culture of an institution. So if you look at it, we cannot really make generalized statements. Like in India, there is nothing like Indian culture. We have different cultures in India. Fine. So we need to be aware of these differences as well. So when I talk about the culture of an individual, so you'll find that some of the teachers may be too strict with time, and some of them may be too lenient or casual with time. So if you are delayed by 1 minute in joining, some teachers might not grant you permission. Others might grant you permission even after joining of 15 minutes of the commencement of the class. Likewise, the institutions might also have their own cultures. So like in IITs, non-performers are never looked at with any kind of sympathy, because the system always, places high respect to performers. So, cultural barriers are very, very prominent, and it is very important for you because you may be working in a multicultural setup where you will have people belonging to different places, different nationalities. So if you want to communicate with them freely without any kind of inhibition or any kind of difficulty, first of all, you have to be more open-minded, tolerant and courteous, and keenly perceptive of the non-verbal symbols, because if they feel something bad, they may be signaling that and you need to take care of that. So if your counterpart does not like you to be too creepy, you don't do that. If they don't like you to come closer to them, don't come too close to them. If they don't like talking to you about something, don't talk about something. So what you need to be is, you have to be more open-minded, tolerant, courteous, and keenly perceptive of the non-verbal symbols. Observe their social behavior, values, and analyze them so that these cultural barriers may be mitigated. So it does not come as a surprise that, you know, those who go to Germany for doing research, or they go for pursuing higher studies, or even for you know, internships, they are required to undergo some kind of specific cultural training, maybe for 1 week or 2 weeks, by their respective embassies. I'm just giving one example of Germany, but then there can be other countries also, where, you know, their embassies ensure that the people who are going to their countries are beforehand given some kind of cultural training, so that they are not found wanting. Fine. So this will help in removing cultural barriers. There can be ethical barriers related to different kinds of ethical practices and dealings. In some of the organizations, you know, giving gifts for getting something done may be a norm. In some other, it may be treated as bribe. So when you set some high ethical standards, you must stick to that. And if you try to breach that because of your malafide intentions, then also that will be a barrier in communication, in the sense you may be misinterpreting facts due to your vested interests. So most of the top organizations always care too much about the ethical standards of their employees, and they expect high ethical standards and high levels of commitment and loyalty from them. And for doing that, they don't only keep reminding them the ethical standards that are followed, but they also take strict action against people who deviate from those ethical standards. So I can again give you one example of IIT. In IIT, if you cheat in exams, this is treated as you know, a breach of ethical standards, and strict action is taken against students. Sometimes your exam may be terminated, sometimes you may be expelled, sometimes you may be rusticated. So, you know, these ethical standards are also very, very important. Apart from that, sometimes you might run into legal barriers unknowingly, because you don't know what legalities are involved in a process. And mostly it happens that we make those pieces of information public, which are supposed to be confidential and private. So, you know, that's why most of the firms now prefer graduates who also have some knowledge of legalities involved in the work that they are doing, or during internships and trainings also, they are made aware of them. Apart from that, dear friends, I can mention just passingly 2 or 3 more major barriers that you might look at. One of the barriers may be gender barrier. So different genders might have different expectations and different ways. I can just give you one example, how males and females behave differently and have different you know, expectations, different role expectations. So you will find that the kind of ease you have with a friend of the same gender, you don't have the same ease with the person of the other gender. So this might also create some kind of barrier, and you need to take care of each other's sensitivity, and we need to respect each other's you know, worldview. The second is physical barriers. Now these physical barriers might arise because of some physical problems, like I'm trying to reach you, and then I find that the roads are blocked, or there is heavy landslide on the way, and that's why I'm not able to reach. So these physical barriers, these kind of physical barriers, when there is complete disconnect, they also cause communication disruptions. So you'll find that if storm comes, all means of communication are disrupted, and as a result, the communication is affected. And likewise, there can be language barrier. If you're talking in a different language which is not understood by the other person, that might also result in some kind of barrier. So friends, these are some of the barriers. Many more may be there, as you discussed the other day, but these are the major barriers that I wanted to discuss. This is all. Thank you very much. If you have any questions, please feel free. We can take them up quickly. In the next class, we'll be talking about stage fright, and that will relate to your presentation skill or public speaking. Any questions?
Sir, will you share this PPT?
Yes. I'll share this PPT now that I have completed both the topics. So I'll share this with you, okay? I'll put it here itself, so you can take it from your team, both process and barriers.
Yeah, thank you.
Sir, when will the quiz will happen?
What?
Quiz.
We don't have quiz right now.
Okay, sir.
Okay. So.
Sir, I have asked something in the chat box.
Yeah. Let me see. What is the syllabus for MTE? Yeah. Sir, can you please give us the example of that well-worded no? Well-worded no. That's interesting. Yeah. I can just give you one example, like I gave you one example that whenever we send our proposal to a foreign university, or let's say I'm sending my paper for publication to an international journal, even if they have to say no, they will never say it bluntly. So they will start like something, dear contributor, we are so happy to receive your contribution. We appreciate your valuable thought. Your paper has lot of quality. You have done this, you have done that. Unfortunately, at this point in time, given that it does not fit the emphasis area of our journal, we are not able to accommodate it or include it in our journal. We hope that this will not disappoint you from submitting your papers to our esteemed journal in future. So this is about well-worded no. Did you get that, Sam?
Yes, sir.
Yeah. The other question was, what is the syllabus for MTE? Whatever is covered till MTE will be your part of MTE syllabus. Abhishek says, sir, class timing will be from 5 to 6 on Monday or on Friday 8 to 9. Abhishek, unless and until your CRs agree and give me an alternative slot, the original slot of 8 to 9 will remain. Fine? So please let me know. Yeah. Somebody is asking remedies to ethical barriers. Tanmay, it's a difficult thing. But remedies to ethical barriers are that people should set high ethical standards in their life and will value honesty, integrity, and loyalty. And this can be ensured and assured by your respective organizations also. If your organization is taking good care of you and your family, I believe, if you are working for Reliance Industries, and Reliance Industries is providing you not only a good salary, but is also taking care of your family and special needs, your medical needs, obviously, and is sending goodwill messages on all occasions, like your wedding anniversary, your daughter's marriage, your birthday. You will certainly feel good about it and will feel you will think twice before cheating such a company. Fine. So I think, and then again, the company might set such high ethical standards, and the moment somebody is found breaching them, is dealt with very high-handedly. That will also send a good message. So as I, as I said, in IT, if somebody is found cheating, then he or she is rusticated from the exam or from the institute, and that sends a message to all other people that if you do such a thing here at IIT, you will not be spared. Or Aryan is asking, sir, what will be asking quizzes? I'm not aware, Aryan, what quiz are you talking about? Have you received any communication from the course coordinator regarding quizzes? Yes?
No, sir. When it will happen then? CWS I'm talking.
CWS are you talking about? So I'll have to discuss with the tutorial teachers. Fine. But then quizzes will be based on your understanding of these topics only. So in the next class, we'll talk about non-verbal communication first. We'll talk about body language and non-verbal communication, and then after we'll move on to stage fright. Okay. Okay, fine then. See you. Unless agreed, see you on Friday 8 to 9. But please let me know all the CRs. Discuss with your respective members. And please let me know if you want any shift in the class. Fine? Okay then, thank you. Thank you very much.
Thank you, sir.
Thank you, sir.